Okay, so we're going to go to the OneNote and there we go. Okay, so just go over to my math tab. Okay, so I think I just let Riley in there. If you didn't get in, let me know. Okay, let's do a new section. Okay, so unit, we'll call it unit 5, and it's going to be trigonometric functions. Okay, so the good thing about this first few sections in the book, it's almost a repeat of Math 11. So section, it's actually called this 6.1 in the book, and it's called trigonometric functions. So I'm just going to switch over here. Okay, so here we go. Let's turn that around. Okay, so there's a bit of terminology here. I'll write down some of the keywords here. So one of them, where are we here? Draw. So let's take a look at terms like angles and standard position. So let's mute this. Okay, now when we draw an angle in standard position, we have sort of a starting point here. And our starting point's always to the far left at 0 degrees. And when we rotate angles, obviously if we do a full turn, it's looked at as being 360. So sometimes in some books, you'll see this written as 360 over here too. But when the angles rotate, a positive angle always rotates in a counterclockwise direction. Sorry, some feedback. And so really at the top of the arc here, this would be 90 degrees here, 180 degrees, and 270 degrees. And so when an angle is plotted this way in standard position, we always start at 0 and we rotate counterclockwise if the angle is positive. So this would be for positive angles. And then we rotate rotate clockwise if it's a negative rotation. So I'm just going to sketch an angle for you. So let's say we're going to have to sketch the angle 130 degrees. So we're not asking you to like measure this with like a protractor. It's just really a rough sketch of where the angle would be. So all you have to do is just draw a little grid for yourself. And now obviously 130 is past 90, but it's not more than 180. So we would say that the angle would stop somewhere over here. And then to draw that, we start at the sort of starting arm, and we draw that. And we say that that's about 130. And you don't really have to be that exact. What I'm marking you on is that line here, this line here, is it in the right square really, like it's in the right spot. But there's some terminology I should probably throw out here because like I'm not really using the proper language here. But the first thing is quadrants. And so there's always 4 quadrants on the grid. Usually they use Roman numerals for them, but I'm not sure why they have chosen that. Romans were long dead and gone before we use those numbers. So the quadrants are numbered 1 over here, and then quadrant 2, and quadrant 3 down bottom left, and then quadrant 4 on the far right. And sometimes we'll ask you, where does the angle stop? And so for this angle, we say it stops in quadrant 2. So the angle stops in quadrant 2. Now, the arms of the angle are always given special names too. So this arm here where the angle starts, that's our red line there, we call that the initial arm. Or sometimes in the book, they'll use the word ray. You might say initial ray. And then where the angle stops, this I should have switched my colors here. Red means stop. But anyway, green, we'll say here, this is called the terminal arm. So the angle always stop at a terminal arm, and that terminal arm will most likely be in one of the 4 quadrants, although it could maybe be at one of those places in between the 2 quadrants, and we'll talk about that in a bit. Another word you would have learned last year is the reference angle. And a reference angle is probably the most important thing to find on the diagram. It helps us solve like a lot of what might seem like really complicated questions. And so I'm going to write out the definition for this, although you don't have to memorize it. But the definition is the acute angle between the terminal arm and the x-axis. And so there's 3 parts to this definition you really got to be careful about getting right. And it's actually quite surprising what students get most confused in this definition. Terminal arm students tend to get pretty quickly because they sort of know it's where the angle stops. Acute, you think that would be like one of the harder words, which means less than 90 degrees. It's actually this word that students seem to mess up a lot on, and they get confused between which one's the x-axis and the y-axis. So in the picture I drew here, I'd like you to take that definition and just draw a little like let's say this is the angle and you're drawing that part there as the angle. I'd like you to draw where you think the reference angle is on this picture. So in this picture here, where do you think the reference angle is? And if you find it, I'd like you to figure out what is the measurement of it? Like how many degrees would it be? So that is, what is the reference angle for 130 degrees? Okay. So the terminal arm is this line here, we said. That's the terminal arm. The x-axis is here. It's the x-axis. And now we're looking for the angle that's between those 2 lines, but it's the one less than 90. So obviously you've got this 130 over here, but that's not acute, that's obtuse. So that angle is bigger than 90. So it'd be the angle on the far side over here. So that would be our reference angle. So in this question, the reference angle would be, well, basically, let's call it x. X plus the 130 would have to equal 180 degrees. So the angle x here plus the 130 would have to equal 180, or you could say x is 180 minus 130. So the reference angle must be 50 degrees then. Just a quick check. I can see Kyle here. Is my voice loud enough, Kyle? It's good? Okay, just making sure. Sometimes people were saying I was fading out in the last video. So, okay, so lots of terminology coming your way. So you got initial arm, terminal arm, reference angle, acute, x-axis. And the other big word you would have learned last year is what's called a coterminal angle. Now, terminal here, has something to do with the terminal arm, so that's related to the terminal arm. And then co, the prefix co, meaning to share. So basically, it's any angle that shares the same terminal arm. So before we give you a definition for it, I want you to draw or sketch this angle. I want you to sketch the angle 220 degrees. And once you've sketched it, so do a quick sketch, I want you to find the reference angle, and then we'll talk about coterminal. So I always find it useful to put the numbers on the grid to help me keep track of where I am. And so if I'm looking at 220, I'd have to start at 0, and I'd have to move through the quadrants and then stop in a quadrant where 220 would stop. So 220 being bigger than 180 but less than 270 would have to stop somewhere in quadrant number 3, somewhere over here. Okay, and once again, if I'm approximating that number, I don't know, maybe about there. It's not quite in the middle, I guess, but somewhere there. And then once again, there's two things you want to draw. One is that line, so that line we just drew there. And you also want to show the angle where it is. And it'll make sense why we're showing that when we start talking about coterminal angles, I think. But let's find the reference angle now. So the reference angle would be this angle in here. That would be your reference. So that's the angle between the terminal arm and the x-axis. Okay, so I know that the angle itself is 220 degrees. And I know that half a rotation, 180. If I was to subtract that 180, so I'll just sort of show that on the picture here. So if I subtract this part, I should get the reference angle. So 180 taken away from 220 would be a 40 degree angle then. And so that's what our reference angle would be. Okay, so I'm going to just erase that little red part. Now let's talk about coterminal. Okay, so we said it's important that when you draw the angle, you start on the initial arm and then turn and go towards that arm there. So the reason that's important is coterminal angles. They're basically any angle that starts at 0 but stops on that angle or that terminal arm. So for example, if you drew this, if you said this is an angle, that red angle would be coterminal with the purple angle because they both stop in the same place. So let's call that theta 2. We'll say our purple angle is theta 1, our first angle. Okay, so let's find theta 2. Let's find the other angle that would stop in quadrant 3, but would actually be going the other way now. So one way to do that would be to say, well, it's 180 to do a half turn, and the reference angle was 40. So this red angle must be 180 minus 40, which is 140. But because it's rotating the other way, it has to be negative 140. So negative is just like a direction. If you've ever done physics before, you get negative vectors and positive vectors and stuff like that. So just really a direction. Okay. Now let's do one more angle. Let's do theta 4. And theta 4, I'm going to have it start on the initial. I always have to start on the initial. Let's go around. Let's stop there. So we're going to stop on the same terminal arm. See if you can find out what that angle would be. You might want to use your calculator. Some of these numbers are going to get bigger on us. So okay, so one way to look at that is basically if you want to get back to that line, you would have to go around. So in order to go around, you have to do a full circle. So how many degrees is there in a circle? Well, there's 360 degrees in a circle. So if we take the first angle, 220, and we did another rotation, let's say 360, then that should give us a new angle of 580 degrees then. So 580 is the same, sorry, the 580 is located in the same place on the graph, but it's obviously a different angle. So if someone said, you know, turn 220 degrees, that would be quite different than turning 580 degrees here. So really, how many coterminal angles are there? And then how would we determine them? How can we find them relatively quickly? Well, we talked about in the last video the concept of infinity when it comes to geometric series. And so really there is an infinite number of rotations. If you just think of a bicycle wheel, you could turn that multiple times and stop the wheel wherever you want to. Or if you're on a Ferris wheel and you kind of get on the bottom. And I actually realized that I actually am scared of heights on a Ferris wheel. Last year I went to Disneyland with my kids and I went on the big Ferris wheel there. And when I got to the top, I realized my palms were sweating and I was quite nervous. So I must have a fear of heights. Great time to learn it. So anyway, and then you go all the way around. So on a Ferris wheel, the wheel just keeps turning and turning and turning and turning. And so really, to find another angle that's coterminal, you just take the first angle and you either add or subtract 360 degrees or some multiple of that. So where n is an element of the integers. So for example, if you wanted to do 5 rotations, you could say, well, let's find a fifth angle for the one above. We'll take 220. That was the first angle we gave you, 220, and we'll go 360. And let's go around 5 times. So we'll do 5 rotations. So you're probably going to need a calculator here. So 360 times 5, that's 1800 degrees plus the original 220 gives us 2020 degrees. And so you could just keep rotating and rotating and rotating, and there'd be an infinite number of angles possible. One of the words they use in the book, although I don't test you on it, but it's sort of helpful to know, is the principal angle. And so the principal angle is basically, of all the coterminal angles you can come up with, it's the angle that's between 0 and 360 degrees. And so that's actually usually what I encourage most students to do to find out critical things like the reference angle. So let's give you an example of that. So let's say you had theta equaled 5,000 degrees. Okay, so that's a huge angle. That's hard to conceive. Like, how many turns is that? And someone says find where the terminal arm stops. Or maybe find the reference angle. So, I mean, once again, I think trying to draw 5,000 degrees, you're going to lose your mind trying to draw that number of turns. So what you could do is think, well, what would be coterminal with that? Like, how could I draw a smaller one? And so the principal angle, this principal angle here, if we could find out which angle between 0 and 360 is in the same place as 5,000, then it would be very easy for us to find the reference angle. So what you could do is just keep minusing 360, like, 5,000 minus, 5,000 minus 360, minus 360, minus 360, and finally wait until you get a number in that zone. But what might be faster for you if you have a calculator is just take 5,000 and divide it by 360. So take 5,000 degrees and divide it by 360. And if I do that, it's not going to go in, whoopsie, it's not going to go in evenly. But if I take 5,000 and divide it by 360 degrees, I'm getting about 13.89-ish kind of thing. So what that tells me is that that's about just under really 14 turns. So if I went around the wheel 14 times, I'd be pretty close to that place. So why not subtract 13 rotations? So let's take 5,000, and then we're going to do is subtract 360, but let's do 13 rotations. So not quite the 0.89. We'll leave the 0.89 out. And so if I do that, I go 5,000 minus 360 times 13. I'm getting 320 degrees. So Kyle, Peter, David, or Jessica, fingers up. Which quadrant is 320 in? 4. Okay, quadrant 4. Good. So quadrant 4 here, somewhere over there. Okay. Now, if I draw that picture, I just drew 320, not 5,000. But the question didn't ask me to draw 5,000 because I'd have to go around 13 times, 13 rotations. All it wanted to do was find the terminal arm where it is. So that's quadrant 4. You guys already answered that. So quadrant 4. And then I guess the question is, how would you find the reference angle now? Well, the reference angle is the angle between the terminal arm and the x-axis. So that would be the reference angle. And we know that a full turn is 360, and the one I just drew was 320. So that's the 320 I just drew. So the difference between 360 and 320 would be 40 degrees. So this would be a 40-degree reference angle. But I think trying to draw, like, I don't know, like, I mean, if you wanted to draw, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then over there, that's kind of what that would look like. Like, I don't know if you want to draw that. That's pretty kind of trippy. Okay, so once again, a lot of review from last year, I hope nothing too new here. But I am going to show you one new thing, and you're going to really need to have your calculator beside you right now. I'm going to give you some time to get your calculator organized. This won't make a lot of sense without a calculator, I don't think, at this stage. So what I want you to do on your calculator is I want you to find on your calculator, press the sign of, where's it here? The sign of 30 degrees. Okay, so if you can press the sign of 30 degrees, that would be really, really helpful. Now, you should get 0.5 as your answer, so this should be 0.5. Now, if you're not getting 0.5, it's because your calculator's on the wrong mode right now. And you'll notice on the school calculator, at the very top left, the second button over is the button DRG. Okay, and so what you want to do is you want to press. You could just do it even right now if you want. Just press that button, and what you want to see at the very top of your calculator is DEG. Okay, and that means your calculator now is in degree mode. If you're using a different calculator, there should be some place on the calculator where you can change the mode setting and alter things to go to degrees here. And so I'm going to get you to do one more calculation. On your calculator, if you can work out the sine of 150 degrees. And once again, use your calculator for this, just see what you get here. And you should notice that you're getting the same number. You're getting 0.5, okay? But if you think about 30 and 150, those are two very different angles. Like one is in quadrant 1, and one is in quadrant number 2. So you're getting two different numbers here. Okay, so let's move on here. So let's take a look at something that's a bit strange here. So I'm going to take a look at a circle. Just draw your best circle. That's really a bad circle, but whatever. Okay, and then I'm going to draw my grid on that. So over here. Really kind of sloppy looking circle here. Okay, and I'm going to make this 0 degrees, make this 90 degrees, make this 180, and make this 270. Okay, so now we're going to do something that should be very new for people. Okay, so you probably haven't done this before, unless you've been reading ahead or something. And what I want you to think about is back in grade 9, your teacher would have taught you this formula: C equals 2 pi r. So C is equal to 2 pi r. So what does the C stand for in that? Is there a meaning to that C? Well, that C is the circumference of a circle. And that means the distance around a circle. So to go around a circle is the formula 2 pi r. Also sometimes written as pi d, but we're going to work with the 2 pi r formula here. Okay. So if you went, let's say you had a circle where a piece of pie maybe. Let's say you were told that it was that C equaled 20. So the distance around this circle was 20 centimeters, say. 20 centimeters, okay. And then they drew a picture where that's the center. They drew that, and they put a little 90 degrees in there, okay. And they were asking you, how far would it be for this blue part right here? The distance between those 2 points. Well, if that's 90 degrees, how much of the circle does that represent then, I guess? So if you look at a circle being 360 degrees, and you rotate 90 degrees, well, then you would have covered 1/4 of the circle. So 90 over 360 is equal to 1/4. So if the entire circumference is 1/4, what is the length of x then? Like, what is that distance? Well, that should be 1/4 of the circumference then. So 20 divided by 4 would be 5. So that should be 5 centimeters. So I'm hoping that math kind of makes sense. That's kind of looking at proportions and a bit of idea of fractions and stuff like that. But this concept is really important to what we're about to get into, which can be probably the most confusing part of the chapter. And so here we go. So the radian. So the radian has a specific definition. It is the angle created when the arc length is the radius, or is equal to the radius. And I'm going to draw you a picture of that because that definition doesn't really help very much, probably the way I've written it. But if you drew a circle, okay, that's not good. Here we go. That's a better circle. There we go. Okay. So if you draw this circle, let's put a center in here. So I'm going to put a little dot in here for the center. Okay, and I'm going to draw a line here. And I'm going to say this obviously is the radius. So that's the radius there. And what I'm going to do is I'm going to draw an arc here. And I'm going to try to make it about the same length as that R. So maybe about there. So that's R and R. So if this arc length is R, then this actually is what a radian is, 1 radian. Okay. And the radian, we'll talk more about this in another video, but the radian is really important for trigonometry because it tells us two things. It tells us what the angle looks like, how big it is, like in terms of like 360, but it also tells you how far you've gone. So the unit degrees doesn't tell you that. Like if I said turn 180 degrees, you could just turn in your chair right now and look behind you. That would be 180. But sometimes if you're talking about angles, you might be on an object on a wheel that would turn a certain, like imagine you're a point on the outside of a wheel. You could turn a certain number of degrees, but you would have also covered a distance doing that. And so the radian helps us do both those things, whereas degrees won't. So all I want to do today was talk briefly about the radian and show how we can get it to answer, or sorry, how we can relate it to degrees here. So I'm going to write a ratio here for you guys. I'm going to say this angle theta, let's call that theta there, okay? The angle theta over 360, so that's 1 rotation, should be equal to the arc length. So that is the distance along the arc. Divide by the circumference of a circle, 2 pi r. So this ratio shows the relationship between degrees, so the angle and 360, versus the distance and the circumference. So although they're talking about two different things, these should be related, as they were in the question above. This question up here, we saw that these angles were related to the distance traveled. Okay, so if we're talking about radians, then 1 radian is the angle created when the arc length is the radius. So the arc length, this arc length here, it is the radius, so it is r. So I'm going to say theta over 360 will equal r over 2 pi r, if this is 1 radian. Okay. Now if I isolate for theta, theta will equal 360 degrees r over 2 pi r. And now what happens is the r's cancel out, and 360 divided by 2 is 180 over pi. And if you use your calculator and you say 180 divided by pi, so 180 divided by pi, I'm getting about 57.3 roughly. So really 1 radian is about 60 degrees. It's around 60 degrees here. So still doesn't make a lot of sense probably to that. But let's talk about how we use it now. And we're gonna use our calculators here for this, okay? So I'm gonna say that if you went around a circle, so let's say, so we already said that's 90 degrees up there. That's 180, that's 270, and that's 360. So what I want to do now is talk about how radians fits into this whole thing about measuring angles here. So if you go 360 degrees around a circle, that's really the same as traveling the circumference, which is 2 pi r. So 2 pi r. So let's just make the radius 1 for now. So we'll just say r is 1. We can make it different numbers. But in that case, 360 would be the same as 2 pi. So over here, I'm going to use red for this. I'm going to say this over here is 2 pi. So that's 2 pi to go there. Now, of course, halfway around a circle is 180 degrees. So 360 divided by 2 is 180. So 2 pi divided by 2 would be pi. So over here is now pi radians. And I'm going to go divide that by 2 again, so say 90. And that's going to give me pi over 2. Okay, so here's where I want you to use your calculator now. Okay, so you're going to have kind of quick fingers here, just like you're texting your friends. And I want you on your calculator now to type in the sine of 90 degrees. Okay, so if you type in sine of 90, once again, make sure you're on degree mode. So sine of 90. And you should get 1. Okay, and now let's take half of 90. Let's go to 45 degrees. So if I divide 90 by 2, I get 45. So if I divide pi over 2 by 2, I get pi over 4. And now I want you to type in, once again, still staying in degrees, the sine of 45 degrees. Okay. And you're going to get kind of an ugly number here for this. So the sine of 45 is 0.707, say. Okay. Okay, now what I want you to do is with your calculator, I want you to switch to radian mode. So turn your calculator from degrees to radians. So that's that DRG button. Okay. And now what I want you to do is find the sine, use purple here, is find the sine of the angle that's the same as 90 degrees. So if you go back to your table here, up here we said 90 degrees was the same thing as pi over 2. So type in the sine of pi, divide by 2. And then also type in the sine of 45 degrees, but in radians, which is pi divided by 4. So if I type that in, I should get 1 here, and I should get 0.707. Okay. So there is a connection between obviously the radians and degrees, and once again, it's always going to, it takes a few days to have this click for us, so don't be too alarmed if you're not sure what's going on. But I want to go back to this chart here. What I want to do is I'm going to take 90, and I'm going to divide it by 3 here. So that would be 90 divided by 3 is 30 degrees. Okay. And if I do the same thing over here, if I take pi over 2 and divide it by 3, that's going to give me pi over 6. Okay. And then I'm going to times that by 2, which gives me 60 degrees. And if I times pi over 6 by 2, I get pi over 3. And that's all I'm going to do for these special numbers here. These are sort of special numbers for us. And so once again, I'd like you to since you're already in radians, I want you to type in the sine of pi over 6 and the sine of pi over 3. But once again, make sure you're in radians here. Make sure you're in radian mode. So the sine of pi over 6. And once again, you have to be in radian mode for this. Sorry. Sine of pi divided by 6. And I get 0.5. And if I do the sine of pi over 3, is that right? Sine of pi divided by 3. I should get 0.8660 roughly. So that's good. Okay. So now if you switch back to radians and you type in the sine of 30 degrees and the sine of 60 degrees, you're going to see that you actually get the same numbers as these. So radians and degrees are just different ways of measuring angles. And that's really the big change, I would say, from Math 11 to Math 12 is trying to get good at using the radian measurements here. So this box that I've shown you here with all these angles, these are what we call our special angles. And I would definitely take some time to make the connection between, sorry, special angles, between the degree measurement, so that's degrees, and the radian measurement. So for today, I would say that this might be a bit much in terms of making this make sense right now. But I guess the big thing I want you to walk away from is that degrees and radians are just different ways of measuring angles. There's another thing called, probably not the best word to use right now because I heard you guys got an email about this. Is the grad setting on the calculator. We don't use grad, sorry. But you guys will graduate though, okay? So just you'll have to have your own kind of cyber party or something like that, okay? We'll talk more later about other math stuff. So I'm going to end it off here. So I'm going to stop sharing. I'm going to upload this video to our Google Classroom, and it'll also be, if you click on the notebook feature, you'll be able to see all this information there. So if you haven't written it all down, you can always go back and check it. So let me just switch over here from not sharing, and I'm going to stop